Kelly. So Jane's a senior lecturer in Livestock Production Management at Sturt University and a researcher within Sturt's Gulbahati Institute. Jane's most recent experience explored the opportunities and limitations of remote sensing for weed detection in a complex landscape. Her and her colleagues have set up a community of practice around remote sensing, which is fantastic, and also has created some online guidelines to enhance the uptake of remote sensing for weed detection as well. So Jane's going to talk about the opportunities and limitations of new remote sensing and AI tech as well in terms of weed detection and mapping. So over to you, Jane. Thank you.
Thanks, Justin, and thank you everybody for having me. Hopefully you can hear me okay. Great. All right, I'm just going to share my screen. How's that? That sound okay?
That's looking great, thanks.
Okay. So this project came to its end in July this year. It's been a project that's been going on for a little while. So I'm going to talk about what we did in this project, who was involved, and particularly some of the outcomes that we've been able to achieve with this project, which sort of aligns a little bit with some of the work that Carlos has been doing. So the project sort of stemmed out of a time when we saw that there was some significant gaps in the technology and AI world for weed detection, particularly in heterogeneous landscapes. There's a lot of research that's been done in crops, monocultures, and there were a lot of people working in silos across Australia. And our approach was to try and bring that together in some way to try and facilitate education and to help us learn further about what this tech can do. So we put together a 4-year project that went from 21 to 24 and funded by from DAF, Department of Agriculture, Forestry and Fisheries. And we were looking at basically investigating 3 model weed systems that would enable us to test this technology. So what were the limitations and opportunities of different sensor technologies and different platforms in mixed landscapes or heterogeneous landscapes? So looking at your RGB, your multispectral and hyperspectral sensors on both UAV or drones and satellite platforms. We looked at 3 different weed systems and landscapes to test this, and they differ in their management objectives, but also their growth habit and their location. So hawkweeds were chosen in Kosciuszko National Park, which is a herb, African lovegrass in the Snowy Monaro region, and then bidu bush, which is a shrub on the north and south coasts of New South Wales. Essentially what we did was to find 3 to 4 study sites per species, and we were aiming to target those plants when they were in different phenological stages. So flowering, non-flowering, height off, so we could then identify the perfect time to be able to take the imagery. We took some vegetation assessments by placing different size quadrats around the target plants, a bit like what Carlos just showed. And within those quadrats, we took some information about what was actually there, both on the target species and the non-target species. And this allowed us to create an imagery ground truth of what was actually there and then compare it back to the later predictions. We took some RGB, multispec and hyperspec imagery flown at various heights and therefore pixel sizes across the landscape. And we used UAV and satellite platforms to do that. And so down the bottom there of that slide, you can see a bit of a pipeline which involved imagery processing, development of an orthomosaic of the site, doing some labeling, developing the code and the models, and then validating that model and leading to detections. So some of this work was to try and look at pipelines for different imagery as well. So just a quick summary of what we tested, different cameras across different platforms. And so I've put pictures here of the orange and mousy hawkweeds, or African lovegrass, or the bidu bush. So you can see that for all 3 species, we used RGB cameras. We also used multispectral cameras for a mousy hawkweed, but we did need to use New Zealand data for that because there just wasn't the infestation size here in Australia. And both those sorts of hawkweed species are eradication targets in New South Wales. And then we got bidu bush and African lovegrass information from all the different cameras other than your hyperspectral camera. And that was basically due to some issues we had with wind on the day. What we developed in terms of pipelines, well, we were able to see that there is this common pipeline that's going to be needed when collecting data for weed detection, starting from on the ground with your ground truth data, what's really there close to the naked eye, and then your aerial data, right through to pre-processing, getting that imagery ready to put through a labeling software to be able to tell, then train that algorithm what the target species is versus non-target. And Carlos alluded to the importance of people with weed expertise at that point in time. Then we've got the models that are trained to determine what are the most efficient models, the best models to use for particular species, to then evaluate those for their comparison, their accuracy essentially, which would work best, and then be able to predict, make a prediction map essentially of the species in that site. We produced a number of outcomes, and some of the slides I'll show you in a minute will show you the complexity of that. Looking at, for orange hawkweed, we're focusing on deep learning using the YOLO version 5 model, object detection model with our RGB imagery, whereas with Bush, we used a different approach with the unit segmentation model with multispectral imagery. And then we also had some lovegrass detections using a deep learning CNN model. And then African lovegrass, again, is different because we're using satellite imagery, and that was more of a machine learning approach using multispectral imagery. So we aim to do a lot of different sensors with a couple of different platforms, trying to work out which machine learning algorithms were best. So we worked pretty hard to try and get as many of those as we could. And this is not meant to show you the detail of these slides, but just to show you the complexity of the models that we tested. And you can see here from the hawkweed ones that we looked at both target species, different computer vision techniques were used in the imagery, whether they're bounding boxes or perimeter boxes around the targets. The different drone imagery we use this with the different sensors. So Microsense Alta multispectral camera versus a Sony, two different Sony RGB cameras or a Fujifilm RGB camera, and different pixel sizes for each of these, versus flower, foliage, or flower heads, and the different sites that we used, and the different models that we tested, from which we then selected the most effective model for use with that particular imagery. And we did the same for Bush. You can see here across the south central and northern coasts, and then for satellite imagery as well on the same sites. And we used 50 centimeter SkySat imagery, which we are able to obtain from one of our partners, which I'll talk about in a minute. And then again, for African lovegrass, a number of different models that we tried different applications with to determine where this plant was. And that was a real hard one because African lovegrass is a grass and looks very similar to the other grasses. So grasses can be a real challenge, particularly that species. And that's our satellite imagery as well. And I'll show you in a moment if you can access if you're keen and have this expertise. We have a place where all of that has been documented. But the key challenges that we found out of this project were the technology and field challenges. So just understanding how the cameras are put together, how they talk to the UAV, and also in terms of the AI technology as well. We've got field challenges, wind, light, going out to remote locations, and therefore, an update occurring when you're in the middle of trying to collect data. All of these different technological and seasonal challenges that can make collection of this data really difficult, and a lot of planning needs to go ahead before each mission. And you can see there, we're us on the beach. We had issues with sand, and wind coming across the coast, pushing our drones around, which was, when they're quite expensive, is something to consider. Labeling, that was a really big bottleneck for us. Labeling, again, as I said, is the process of getting a weed expert to identify in the imagery where the weeds are, and to be able to annotate those using particular software. And that takes a long time, particularly when you've got a number of weeds across a single image, and you have to be very careful to identify correctly which weed is the weed and which is not, because oftentimes you get lookalike species in the same image that can look very alike to our eye. And so we need to be very careful about labeling that correctly, and just having enough instances to label is really important for deep learning models. They need a lot of training data to be able to work effectively. So that was a real bottleneck for us. And then there's data storage and access. Data storage is, some of these are huge data sets. And so that costs money to store. And then to provide access to that, there needs to be a more common way to share that. Alignment of imagery is important in terms of datums. A lot of people use one datum and then you're collecting data with trying to align it with another datum. So being able to keep that in mind is important so that you can get alignment of imagery. And then accurate field validation as well, being able to really report accurately what is being seen on the ground, so that the prediction maps, we can be really sure of what we're seeing in the imagery when we compare them. And again, it's important to document the failures and tech limitations so that we can, avoid losing our resources. And so all of these learnings was clear that, a lot of people were struggling with similar things. And so we developed the Weed Remote Sensing Community of Practice, which is a cross-sectoral community of people working in this space, from government to universities to land care to students. And it now spans outside Australia to New Zealand, Inner Mongolia, the UK, and New Zealand. Have I mentioned anyone else? Israel, a couple of Israel people too. So we're hoping to grow it further. And what we're aiming to do is just to try and keep bringing together people in this space to learn from each other, to network each other, to provide learning opportunities of what people are doing so they can connect later on, and just to develop and share information and support each other. And that's, I've got the QR code, but I'm sure, you can get my details at the end of this presentation if you'd like to join up. It's free and we just meet quarterly online. And then we developed the Weed Manager's Guide to Remote Detection, which is hosted by our Golbali Institute at CSU. That's a bit of a screenshot there of the opening homepage. And in there, we've got different applications, tabs showing the different aspects of weed detection. And it's more aimed at your intermediate person, maybe someone who's coming in for the first time or has just been working in this for a while. This is a highly technical field, and computer vision particularly is a science in itself. But in terms of documenting the process and the things to be aware of, we've sort of tried to put that together in a way that's user-friendly and therefore links to other people and other information if you want to go further. And so there's menu items like you can see on my screen, things to think about with weeds, but also with data capture platforms, sensors and data analysis. And we've also got some case studies in there of other people and some publications and ways in which to see how all the outcomes from our project, and that's shown in the reports and models page. So we want to thank our many partners that were involved in this. As I said, the DAF has been wonderful in enabling us to complete this work. We're extremely thankful for their support. But Queensland Unity of Technology, New South Wales Parks and Wildlife, and a number of Shire councils as well, XAG, Illawarra District Weeds Authority, I can see David Pomery's here, and local land services have been really instrumental in helping us at various stages across our program. And here again, here's the link and the website, but you can always just email me and I can give you access to both, or you can search for those as well. I think that's me.
Great, thanks, Jane. And with your permission, we might add a link to your repository in the NRM Knowledge Hub, so the NRMs can hook through to you guys more easily.
Everything's shareable from this project, so more than happy.
That's great, excellent.